This is my water tube project. This is what I was hoping for. These are 5-foot length, 4-inch in diameter. There's 4 to a board. There's 3 boards. There's a shaft in the center. Everything is equally balanced. There's bearings at each end of the shaft, and those bearings are mounted on the 6-foot ladders. The water jugs you see are just balancing, helping balance and counterweight the rotation mask on the 6-foot ladders. Those are actually Hawaiian Punch gallons of plastic bottles filled with water. This is the effect that I was hoping. Currently it's empty. If you see, take a look at it or stop it. It has no caps on the tubes. It moves freely. I was hoping for this kind of movement when they were all filled. Consistent kind of movement. I've tried different configurations using this, and I'm going to show you in a minute the best results that I get. This is the other side. I've worked on this project a little while. When they're all filled, this is the result that I get. I get either quarter turns when they're all equally balanced, filled. If I spaced out the tubes, they do not like it for some reason. This is the best results that I get. When they're all equally balanced, I get quarter turns. Quarter turns meaning, if you look at a clock, from 12 to 3, from 3 to 6, or from 6 to 9, or from 6 to 12, back again, quarter. What I'm showing you here is where my finger is at. The top water is at the end, creating more weight, and the bottom tube water is at this end, creating weight on the left side. Therefore, in theory, all the weight, or most of the weight, is on the left side, creating more weight. The teeter-totter effect should have turned it up until the next one grabs hold, and thus the same thing. Again, I have a theory as to why it's not working. I just haven't figured out all the bugs, nor I have the time right now. This is it standing, freestanding. I believe this one's also all the tubes are filled, and I'll show you in a second as to what happens when I move it. A little workbench action there as I picked up something. I'm going back to this thing and I'm going to grab it, and I'm going to turn it. I'm going to set it up so I can turn it. This is the best result that I've gotten out of it by setting it up. If I let it go here, if you take a look at that tube and follow that tube that's in top left goes down. It's coming up right now, and it moves one more quarter of a turn. If you start at 12, consider at 12, it's moving all the way to 9 o'clock, which is 3/4 turns. It's not doing the 360 that I would hope for, but it is. I got it to do a 3/4 turn. And I'm showing you the other side. Here, I'm going to set it up again. That one board is loose. We'll move it. It's going down now, it's on, and it's moving one more quarter turn. Bam. Like I said, it's 4 tubes per piece of wood. The wood measures 2 foot by 2 foot. The tubes are 5 foot long, 4-inch in diameter. There's 4 of them to each plywood. It's not actually plywood, but we'll call it plywood. I think it's solid oak. They're pretty heavy too. A solid shaft, a 1-inch solid shaft in the center. Everything's balanced and matched and centered. This is the result that I get when they're all filled. Pretty much it'll teeter-totter back and forth for a little while. This is the result that I was hoping for. I dream with this result. I was really hoping for this result. Unfortunately, I didn't get the result that I wanted out of this thing.